When China announced new restrictions on rare earth exports in October 2025, it sent ripples through defense and technology sectors worldwide. The rare earth market is small in volume but vast in influence. The metals underpin everything from precision-guided missiles and jet engines to electric vehicles and smartphones. By tightening export licenses for mining, processing, and magnet production, Beijing is asserting control over an industry that it already dominates, raising concern among nations dependent on Chinese materials for their most advanced systems. This is the DEFCON Warning System. If you find these videos informative, like and subscribe so you will be notified of more like this. We publish nuclear strategic updates every Monday, and our community forum is always open to interact with others, as well as the staff of the DEFCON Warning System. Find it at community.defconwarningsystem.com. And of course, visit our website at defconwarningsystem.com. Rare earth elements, also called REEs, a group of 17 metallic elements including neodymium, dysprosium, and terbium, are essential in the production of high-performance magnets, guidance systems, sensors, and stealth coatings. Precision guidance and actuation, neodymium and samarium are used in compact, high-strength magnets that power the servo systems inside missiles, aircraft, and drones. Radar, optics, and communications, europium, yttrium, and terbium play roles in laser targeting, sonar, and advanced optics. Aerospace and energy systems, dysprosium and terbium improve heat tolerance in alloys used in engines and turbines. According to open data, an F-35 fighter may require over 400 kilograms of rare earth materials, while a single Arleigh Burke-class destroyer uses several tons across its electronics, propulsion, and weapon systems. These figures illustrate why policymakers view rare earths not as industrial commodities, but as strategic assets. China's current position stems from decades of deliberate industrial strategy. Beginning in the 1980s, Beijing invested heavily in rare earth mining and refining, tolerating environmental costs that drove Western competitors out of the market. Today, China mines roughly 60 to 70% of the world's rare earth ore, but controls over 90% of global processing and magnet manufacturing capacity. The critical bottleneck is not extraction, but separation, the complex chemical process that transforms raw ore into usable oxides. Beijing has since consolidated its industry into a handful of state-supervised conglomerates, creating an integrated national system that can coordinate production, pricing, and export policy. That structure gives China the ability to tighten or relax global supply at will. Under the new measures announced in October, China's Ministry of Commerce expanded the range of restricted exports and imposed stricter licensing rules. Defense and semiconductor applications will now require specific government approval. 5 additional elements, holmium, erbium, thulium, europium, and terbium, were added to the controlled list. Export licenses may be time-limited, with some reports indicating 6-month authorizations for selected foreign firms. Collaboration agreements between Chinese and overseas companies involving rare earth technology will face new scrutiny. Beijing framed the move as necessary to safeguard national security and protect strategic resources. The policy follows earlier restrictions on gallium and germanium exports, suggesting a broader trend toward resource-based leverage in global technology competition. The rare earth tightening highlights a growing vulnerability in global manufacturing. Nations heavily reliant on Chinese processing, particularly in defense, aerospace, and high-tech industries, face renewed exposure to geopolitical risk. Prices for certain oxides rose sharply in the days following the announcement, and analysts warn that even minor licensing delays could cascade through downstream production. Defense contractors in the United States, Japan, and Europe are already reevaluating their sourcing strategies and stockpiles. While other countries such as Australia, the United States, and Canada hold rare earth deposits, most lack large-scale separation and magnet-making infrastructure. Building that capacity could take years, and even then, environmental permitting and economic viability remain hurdles. The episode illustrates a structural asymmetry. Although the global economy depends on rare earth materials, the processing capability is overwhelmingly concentrated in one country. China's new export controls mark a calculated use of industrial power as a geopolitical instrument. They reaffirm Beijing's command of a supply chain that underpins both the digital and defense revolutions of the 21st century. For now, the world's most advanced weapons, satellites, and clean energy technologies still run through China's refining plants. The question is not merely whether supply can be replaced, but whether it can be done quickly enough to avoid strategic dependency when tensions rise. This is the DEFCON Warning System,